Hello students, welcome to Academy, the place for mathematics and science. Dear students, in the last class we were discussing the chapter real numbers. Now let's go for continuing this, and do remember this is 10th period of this chapter. You all know that the chapter has already been completed, right? And we were focusing on some of the additional problems from different reference books. Most of the types were over. And in the last type of the problem, we had solved two problems. Do you remember them? Yes. Now just we shall go for recalling them. Now you all know that how a number can be expressed, whether it may be an even number or odd number. If it is even, how do you go for writing the general form of even number? Yes, you are right. It is 2q. What about the odd number? It is 2q plus 1, right? If 4q is the even number, how do you go for writing the odd numbers? You are right. It is 4q plus 1 and 4q plus 3. Is it not? I go for taking one more even number, 6q. How do you write the odd numbers? Odd numbers can be written as 6q plus 1, 6q plus 3, 6q plus 5. Then could you tell me what is another form of even number? It is 8q. Then tell the odd numbers. Odd numbers are 8q plus 1, 8q plus 3, 8q plus 5 and 8q plus 7. Is it done? And using this concept, we proved two important statements. One is, what is about n square minus 1? Yes, n square minus 1 is divisible by 8. What is the condition for n? You are right, it is n is odd. We have already proved this statement as well. And one more statement we have proved, n square minus n. What do you think about this? Yes, n square minus n is divisible by 2 for any positive integer n. Right? Now, we have some more important problems are there. Let's go for solving them. I'll write that. Now, I have taken the 11th problem. Just go through this. It is also one of the important type of problem to be asked in the examination. Observe. Show that one and only one out of n plus 2 or n plus 4 is divisible by 3 where n is any positive integer. If n is any positive integer, that means some of them are divisible by 3, some are not divisible by 3. In general, if n is divided by 3, how do you go for writing? Here I write. Just look at it. Let n equal to 3q plus r. Can we write so? The remainder may be 0 or any other number. So, if n equal to 3q plus r, the possible remainders are 0, 1 and 2, right? Then, how do you write the positive integer? We know that the positive integer is of the form. Could you tell how? Here they are given, it is divisible by 3. As I said, some are divisible by 3, some are not divisible by 3. In general, we can write the positive integer is of the form. If you take 0 in place of r, it will be 3q. 1 in place of r, it will be 3q plus 1. 2 in place of r, then 3q plus 2, right? Okay. Now, once you go through that question, show that one and only one out of these three, n plus 2 or n plus 4 is divisible by 3. These are the positive integers. Let us go for trying for these numbers. Here I write case 1. First case. In this case, I take n equal to 3q. When n equal to 3q, right? Observe. First n is there, we have already taken that. Here n plus 2 is there. N plus 2 can be written as, what is n? It is 3q. 3q plus 2. I go for taking next one, n plus 4. Then n plus 4, where n is? It is 3q plus 4. It is equal to 3q plus 4 can be written as 3 plus 1. In these two terms, you can take out 3 as common factor. It is q plus 1, then remaining 1. Right? You just observe it. The first one, n equal to 3q. Is it the multiple of 3? Yes. If it is a multiple of 3, then can we say that it is divisible by 3? Yes. Is divisible by 3. I call it as statement 1. Then what do you say about 3q plus 2? Look here. The meaning of this is, when a number is divided by 3, after dividing, it leaves the remainder 2. Hence, it is not divisible by 3. Next, this is, here see that multiple of 3 plus 1. See, this number n plus 4 is divisible by 3, leaving the remainder 1. Hence, it is also not divisible by 3. Clear? Out of these 3, 1 is divisible by 3. Similarly, we have other two cases, when n equal to 3q plus 1 and when n equal to 3q plus 2. Let's go for taking those also. Here I'll write case 2. What is that? Case 2 is when n equal to 3q plus 1. N equal to 3q plus 1. Then already n is taken. Next n plus 2. N plus 2, that is equal to, what is n? It is 3q plus 1 plus 2. 3q plus 1 plus 2 is 3. You can take out 3 as common factor. 3 into q plus 1. Right? Yes. Next, other one. It is, other number is n plus 4. What is n? It is 3q plus 1 plus 4. This is equal to 3q plus, what is 1 plus 4? It is 5. Can we write 5 as 3 plus 2? Yes. Because I want to take the common factor here. Here 3 into q plus 1 plus 2 will remain. Then what is the meaning of these three? Observe. First one, n equal to 3q plus 1. It means when n is divided by 3, it leaves the remainder 1. Hence, it is not divisible by 3. Next, when here n plus 2, look here, it is 3 into q plus 1. It is the multiple of 3. Hence, it is divisible by 3. If it is divisible by 3, n plus 2 is divisible by 3. Is divisible by 3. Next, what about this? Look here, n plus 4 is written in this way. Here it is the multiple of 3, but 2 is remained, right? Hence, we can say that when n plus 4 is divisible by 3, it leaves the remainder 2. Hence, this is also not divisible by 3. Clear? Now, I call this as statement 2. Then we can go for third case. Could you tell what is the third case? Now, we have to take n equal to 3q plus 2. Here I write. When n equal to 3q plus 2. Observe. What is the second number? It is n plus 2. n plus 2 equal to, what is n? n is 3q plus 2. Then plus this plus 2. It's equal to 3q plus 4. Right? And 4 can be written as 3 plus 1. Now you can take out 3 as common factor. 3 into q plus 1 plus 1. One more number. That is n plus 4, which is equal to, what is n? n is 3q plus 2 plus 4. This is equal to 3q plus, what is 2 plus 4? It is 6. Now can we take 3 as common factor? Yes, it is 3 into q plus 3 how much are? 2 is 6. Now you just observe these three numbers. N equal to 3q plus 2. What is the meaning of this? When n is divisible by 3, leaves the remainder 2. Hence, we can say that n is not divisible by 3. Next, when n plus 2 is divisible by 3, it leaves the remainder 1. Hence, n plus 2 is also not divisible by 3. When n plus 4 is divisible by 3, observe this one, it is the multiple of 3, hence it is divisible by 3. Is divisible by 3. I call this as statement 3. You just observe statement 1, 2 and 3. In first case, n is divisible by 3. In second case, out of these three, n plus 2 is divisible by 3. In third case, out of these three, n plus 4 is divisible by 3. So, how do you conclude from 1, 2 and 3, these three statements? You can say that one and only one out of n plus 2 or n plus 4 is divisible by 3. Clear? So, I'll write the conclusion here. Here, that is from the statements 1, 2 and 3, we can conclude that what? You have to write that statement. One and only out of n plus 2 or n plus 4 is divisible by 3. I hope that you have understood this statement. This is one of the important statement you must learn. Okay. Suppose the same type, if it is divisible by 3, in the same question, divisible by 3, then you can go for taking, divisible by 5, you can go for taking 5q, 5q plus 1, 5q plus 3, 5q plus 2 and 5q plus 4. Okay, now you just go for copying from there to here, quickly. Now, I have given one problem for homework. It is just like previous one, similar to previous one. Go through this. This is 12th one. Show that one and only out of n plus 4, n plus 8, n plus 12 and n plus 16 is divisible by 5, where n is any positive integer. Then how do you go for taking? See, as you are going to prove that any one of these is divisible by 5. If n is any positive integer, means in that there may be a number which is divisible by 5 and which are not divisible by 5, right? Then in general, if a number is divisible by 5, you can write n is equal to 5q plus r. What is r? R equal to the possible remainders 0, 1, 2, 3 and 4. Then the positive integers can be written as, or they may be in the form of 5q plus 1. How? Based on these values. See, when you substitute 0 in place of r, you will get 5q. 1, 5q plus 1. Next one, 5q plus 2, 5q plus 3, 5q plus 4. Got it? Now, you come across case 1, case 2, case 3, case 4 and case 5. In every case, out of these, any one is divisible by 5. Just like previous one only, but in that problem, we had taken any one of those three numbers is divisible by 3, but here 5 they are given. Okay, I hope that you can do. After trying this, then you have to concentrate on 13th one. 13th one, don't go for reading. You only will go for telling the question. Here, I'll write some of the numbers. Observe. 1, 2, 3. How many numbers are there? There are 3 numbers. 7, 8, 9. Here also, there are 3 numbers. Next, it is 12, 13, 14. 3 numbers are there. Is it not? Next, 17, 18, 19. Look here. When you observe all these numbers, what you can conclude? First 3 are they continuous numbers? Yes. Hence, we can call them as consecutive numbers. These are consecutive numbers. Consecutive numbers. Here also we have 3 consecutive numbers. Clear? Then out of these, you can notice that here 3 is there, here 9, here 12, and here 18. What do you say about the numbers which are encircled? They are all divisible by 3. Then can you make a question? Yes. When you go for taking any 3 consecutive positive integers, out of those 3, one is divisible by 3. Go through the given statement. Prove that one of every 3 consecutive positive integers is divisible by 3. Understood? Okay, now let's go for proving this one. Here I'll write proof. Look here. Prove that one of every 3 consecutive positive integers. How to write 3 consecutive positive integers? Yes, here I'll go for writing. Let the 3 consecutive positive integers be. How do you go for writing? Yes, I'll take n plus 1, n plus 2, right? Are these consecutive numbers? No doubt, because the difference of any 2 consecutive numbers is 1 here. Look here, n. Next, n plus 1. Next, again 1 is added to that, n plus 2. If you go for adding 1 to this number, n plus 3, next n plus 4, they are all consecutive numbers. Here we want 3, hence we have taken only 3 consecutive positive integers. Then is divisible by 3. But positive integers, how do you go for expressing that? If in those positive numbers, there are some numbers which are divisible by 3 and some are not divisible by 3. Hence, I go for taking let n equal to 3q plus r. Then what are the possible remainders? 0, 1 and 2. Then how do you write the positive integers? We know that the positive integers are of the form. In which form they are? It is either 3q or 3q plus 1 or 3q plus 2. Right? Just I have substituted 0, 1 and 2 in place of r. Then how many cases we come across? 3 cases. Let's go for one by one. Here I'll write first. Case 1. In case 1, what should be taken? When n equal to, here see the 3q plus r. These are the possibilities. First I'll go for taking 3q when n equal to 3q. Already n is taken. Next number is n plus 1. Here I'll write n plus 1 is equal to, what is n? It is 3q. 3q plus 1. Next, n plus 2. N plus 2 is equal to 3q plus 2. Okay, there are 3 consecutive numbers. Here first one, n equal to 3q is the multiple of 3. Hence it is divisible by 3. It is divisible by 3. I call it as statement 1. Whereas this, when n plus 1 is divisible by 3, it leaves the remainder 1. When n plus 2 is divisible by 3, it leaves the remainder 2. Hence both are not divisible. Out of these 3, only 1 is divisible by 3. Similarly, let's go for second case. Here I take when n equal to 3q plus 1. 3q plus 1. Then observe it. I take second number n plus 1. What is n? It is 3q plus 1 plus 1. It is 3q plus 2. The third number, n plus 2. N plus 2 is equal to, where n is, we have taken 3q plus 1, 3q plus 1 plus 2. It is equal to 3q plus 3. Here you can take out 3 as common factor, q plus 1. Clear? Now you just observe. What is the meaning of this? When n is divided by 3, it leaves the remainder 1. Is it divisible by 3? No. When n plus 1 is divisible by 3, it leaves the remainder 2. And this is also not divisible by 3. Next, whereas n plus 2, look here, it is n plus 2 is the multiple of 3. Hence, it is divisible by 3. It is divisible by 3. I call it as statement 2. Divisible by 3. Next, I go for taking the third case. In third case, we have to take 3q plus 2 in place of n, right? Here I write case 3. In third case, we can write when n equal to 3q plus 2. Yes, I go for writing that here. Observe. N is over. Next remaining n plus 1 and n plus 2. N plus 1 it is equal to, n is 3q plus 2 plus 1. It is 3q plus 3. 3 into q plus 1. Understood? Next, another number. Another consecutive number is n plus 2. N plus 2 it is equal to, what is n? We have assumed 3q plus 2. This plus 2, it is equal to 3q plus 4. How do you write 4? 4 can be written as 3 plus 1. Now you can take out 3 as common factor. 3 into q plus 1 plus 1. Now let us come to know the meaning of all the 3. Here, n equal to 3q plus 2. Observe here. It means when n is divided by 3, it leaves the remainder 2. Therefore, it is not divisible by 3. When n plus 1 is divisible by 3, does it leave any remainder? No, remainder will be 0. Because, see that n plus 1 is the multiple of 3. Therefore, it is divisible by 3. It is divisible by 3. You may call it as statement 3. Now, n plus 2. What does it mean? When it is divided by 3, it leaves the remainder 1. Hence, n plus 2 is not divisible by 3. Observe, in all the 3 cases, out of these 3, n plus 1 and n plus 2, 1 is divisible by 3. Second case, again among these 3, 1 is divisible by 3. Third case, among these 3, 1 is divisible by 3. Hence, from the statements 1, 2 and 3, we can conclude that. How do you write? It is one of every 3 consecutive positive integers is divisible by 3. One of every 3 consecutive positive integers is divisible by 3. Okay, I hope that you have understood. Please copy from there to here quickly. Dear students, we are moving to another important type of problem, and it is also very simple. Go through that 14th one. It is, prove that if x and y are odd positive integers, Then x square plus y square. Square of positive integers, square of odd positive integers is even but not divisible by 4. Don't you feel that it is easier? 100% it is easier. Look here. Once we shall move on to this. Prove that if x and y are odd positive integers. Dear students, we are very familiar with the odd positive integers. In what form they are? It may be in the form of 2q plus 1 or 4q plus 1 and 4q plus 3, right? Then 6q plus 1, 6q plus 3, 6q plus 3, 6q plus 5 and so on. Many are there. Here just they have taken 2 x and y are odd positive integers. We have to assume them. Yes. Here are right. Proof. Let the 2 odd positive integers. Why? Here they are given only 2. X and y are odd positive integers. Let the 2 odd positive integers. Yes. B. What are those? It is 2q plus 1 and 4q plus 1. You may go for taking any 2. They are not given particular. Any 2 are positive integers. Right? We have taken them. Now, let us take the first one as x. Second one as y. What is x? X equal to 2q plus 1 and y equal to 4q plus 1. Both are odd positive integers. Next, let us take the given statement. To be proved, it is x square plus y square is even but not divisible by 4. Here I'll write x square plus y square. What is x? It is 2q plus 1 whole square. What about y? It is 4q plus 1 whole square. It is equal to, now in which form they are? See that it is of the form a plus b whole square. And even this is also. Here I am writing a plus b whole square can be written as a square plus b square plus 2ab. Right? Let me go forward. A square plus b square plus 2ab for this one. 2q 1. 2q 1. Next. Plus again 4q plus 1 whole square. This is also of the form a plus b whole square. Alright. A square plus b square plus 2ab. What is a? It is 4q. B, it is 1. A, 4q and this is 1. It's equal to, simplify that. 2q whole square. Apply square to both. 2 square is 4. Q whole square is q square. Here 1 square is 1. This is 4q into 1 4q. Then this is 4q whole square 16q square. 1 square is 1. 2 4s are 8 into q into 1. It is 8q. Understood? Now let it be in the form, in the standard form. 4q square plus 16q square. How much? It is 20q square plus 4q plus 8q. It is 12q. 1 plus 1. It is 2. Understood? This is x square plus y square. But what we are going to prove? We are going to prove that x square plus y square is even but not divisible by 4. Here I will write. Observe. X square plus y square. Here, can we take 2 as common factor? Yes. Why? Because all are the multiples of 2. See that? 20, 12 and 2. Hence, I go for taking 2 as common factor. It will be 10q square plus 6q plus 2 ones are 2. Clear? Now you just observe the whole statement. In the whole statement you can come to know that it is the multiple of 2. Hence it is divisible by 2. Understood? If it is divisible by 2, x square plus y square is even. Why? And we all know that a number which is divisible by 2 is called an even number. So here I'll write. It is divisible by 2. Therefore, x square plus y square is even. Understood? Okay. Now, let me go for taking again the same statement. X square plus y square. Here, see that in the next statement you are going to prove it is not divisible by 4. Here 20q square, which is the multiple of 4. 12q multiple of 4. What about 2? Is not the multiple of 4. Anyhow, in the first 2, we can take 4 as common factor. 4 into, it is 4 5s are 20 q square plus 4 3s are 12 3q, but 2 should be written separately, plus 2. Then what is the meaning of this? The meaning of this is x square plus y square is divisible by 4, leaving the remainder 2. So here I'll write it is divisible by 4, leaving and leaves the remainder 4, leaving the remainder 2, leaving the remainder 2. Then do you say that x square plus y square is divisible by 4? No. Therefore, x square plus y square is not divisible by 4. Clear? Observe the statement. X square plus y square is even but not divisible by 4. Same thing. X square plus y square is even but not divisible by 4. You can write, if you want to write the conclusion, statement 1 and statement 2. From statement 1 and 2, what you can say? You can say that x square plus y square is, what it is? Even, but not divisible by 4. Divisible by 4. Clear? Yes. Please go for copying from there to here. Yes, students, just go through the last problem of this chapter. It is prove that for any positive integer n cube minus n is divisible by 6. Did you understand the statement? Okay. Just look here. N cube minus n. Can we simplify this? Yes. Because here in both the terms n is there, hence you can take n as common factor. N into n square minus 1. Now n into, it is of the form a square minus b square. A plus b into a minus b. N plus 1 into n minus 1. Look here. N plus 1, n minus 1 can also be written as n minus 1 into n plus 1. Then what do you call these numbers? Can we say these three numbers are consecutive numbers? Yes, look here. N is there. When you add 1 to it, n plus 1. When you add 1 to it, n plus 2, n plus 3, and so on. Here, when you subtract 1 to it, it will be n minus 1. When you subtract 1 in that, then n minus 2. Here, 3 consecutive numbers are there. Then, is it possible to write the same question in another form? Yes. Using this statement, try to tell. You can say that, prove that the product of any three consecutive integers is divisible by 6. Is it okay? Yes. Now, I am going to rewrite the question. as prove that the product of any three consecutive integers, positive integers or negative integers. Here we are preferring positive. Any three integers are just positive integers divisible by 6. Got it? Look here. Here they have given, prove that for any positive integer n. Then what is n? How do you go for assuming? Let n equal to, can we write 6 cube plus r? Yes, because we are proving that it is divisible by 6. n equal to 6 cube plus r, where the possible remainders are 0, 1, 2, 3, 4 and 5. Then what are those positive integers? Then we can write, we know that the positive integers are of the form, yes. How? They are in the form of 6 cube plus 1, 6 cube plus 2, 6 cube plus 3, 6 cube plus 4 and 6 cube plus 5, right? Then how many cases you come across? 1, 2, 3, 4, 5 and 6. Do you consider all 6 cases? Is it necessary? What do you say? Yes or no? Not necessary, right? Then how many cases should be taken? Now I am going to give you the justification for that. Look here. I am taking 3 consecutive positive integers. Here 2, 3, 4. Look here. Multiply them. 2 3s are 6, 6 4s are 24. 24 is divisible by 6. Now I take another one. It is 7, 8 or else simple numbers 5, 6, 7. Now 5 6 are 30. 37s are 210. 210, whether it is divisible by 6? Certainly it is divisible by 6. Look here, in 3 consecutive positive integers, in these 2 cases, there are 2 even and 1 odd. Or there are 2 odd and 1 even. Then how many cases would you like to take? Any 2 cases are enough. You may just go for taking 6 cube, 6 cube and 6 cube plus 1. Case 1, this is case 2. Or you may go for taking 6 cube plus 1, 6 cube plus 2. Did you understand? Okay. Now let's go for taking any 2 cases. I write case 1. What do you take? In case 1, I take n equal to 6 cube. When n equal to 6 cube. Observe. Product of 3 numbers. Here I'll write. Here I'll write, let the, I'll write the given statement, that is n cube minus n can be written as n into n square minus 1. It is equal to n into n plus 1 into n minus 1. It has been written based on a square minus b square is equal to a plus b into a minus b. Here are. Now I go for that. When n equal to 6 cube, we can write n cube minus n. Okay, n cube minus n, which is equal to n into n plus 1 into n minus 1. n into n plus 1 into n minus 1, which is equal to, where n is 6 cube, this is 6 cube plus 1 and this is 6 cube minus 1. Observe here, it is a product, and here what is there? 6. Can we say that it is divisible? It is the multiple of 6? Of of course, hence it is divisible by 6. So we can write here, it is divisible by 6. Similarly, you may go for another case, second case. Here I'll go for taking one odd, that is when n equal to 6 cube plus 1. Then again n cube minus n. Only for the sake of understanding, I am just again expanding it. N into n plus 1 into n minus 1. Substitute 6 cube plus 1 in place of n. 6 cube plus 1 into 6 cube plus 1, this plus 1. Here into n 6 cube plus 1 minus 1. So minus 1 plus 1 get cancelled. It is equal to 6 cube plus 1 into 6 cube plus 2 into 6 cube. Clear? You can rewrite this as 6 into q into 6 cube plus 1 into 6 cube plus 2. See that this is in product form. And it is the multiple of 6. Hence it is divisible by 6. It is divisible by 6. Therefore, you can write a conclusion. For any positive integer n cube minus n is divisible by 6. Clear? Okay, you have to understand it once, then you go for writing from there to here. Write quickly. Dear students, now we are moving to the last concept of this chapter. It has been given in your NCERT textbook, page number 19. That is, we have learned that relationship between the given numbers and their HCF and LCM. When the given numbers are positive integers, just A and B, only two numbers. But here, three numbers are given. Once you go through the statement, see the relationship among A, B and C and their HCF and LCM, where A, B and C are three positive integers. Then what is that relationship? Will you write the product, that is product of A, B and C, A into B into C is equal to product of HCF and LCM? No, it is not equal. Then what is the right statement? Look here. Here, HCF of A, B, C into LCM of A, B, C will never be equal to the product of A into B and C. Then the statement which gives the relationship among these three numbers with their HCF and LCM can be written like this. These two are important. Chances are there. Here I will write HCF of A, B, C, these three numbers is equal to, it is A into B into C into LCM of A, B, C. There are the product of three numbers and LCM of A, B and C. Then divided by LCM of A comma B into LCM of B comma C into LCM of C comma A. Got it? Next, one more important relationship is there. This can also be written in terms of LCM as LCM of A, B, C is equal to the product of three numbers. You can also write like this, into A into B into C. Just in place of into I have written just dot. A into B into C into HCF of A, B, C whole divided by HCF of A comma B into HCF of B comma C into HCF of C comma A. Clear? So these are the two important statements which give the relationship among the three numbers A, B and C and their HCF and LCM. Got it? So with this, the chapter has been completed. Now just I am going to give you the revision by telling only the important concepts to be asked in the examination. And meanwhile, you just go for copying from there to here. Dear students, as I told, the chapter has been completed with all textbook problems as well as additional problems from reference books as well as previous year question papers. Now, it is a time to recall the concepts. I am going to give you only the important concepts what we have discussed so far, and these concepts will also be asked in the examination as well. Look here, the very first point, we focused on the properties of positive integers. There are two important properties of positive integers. Properties of positive integers. Can you tell what are those? One is Euclid's division algorithm or lemma, and another one is fundamental theorem of arithmetic. Both the statements are very important. You must learn that. EDA states that if A and B are any two positive integers, then there exist two unique positive integers satisfying A equal to BQ plus R, where 0 is less than or equal to R less than B. Such a simple. Similarly, FTA, it states that every composite number can be expressed as the product of its prime factors, and this prime factorization is unique apart from the order in which the prime factors occur. Clear? Next, second important point. Here they may ask you to find out the HCF of given two positive integers by Euclid's division algorithm. HCF of two positive integers by or using Euclid's division algorithm. Right? Next, even there is a chance of giving three positive integers also. If I have already told you how to find out when three positive integers are given, you have to find out HCF of first two, then and HCF of this number, whatever the new number you get, that and the last number. Okay. Next, we have come across expressing some numbers in the particular form. If it is even, it is of the form 2q. Odd, 2q plus 1. In the same way, any positive odd integer can also be expressed as 6q plus 1, 6q plus 3, 6q plus 5. They may ask even 4q plus 1, 4q plus 3, or 8q plus 1, 8q plus 3, 8q plus 5, 8q plus 7 in this way. You have to remember that one. That is odd or even positive integers. Next, we know that another important point, square of any positive integer is in the particular form. Similarly, cube of any positive integer, that is also in the form of 9m plus 8. I think you might have remembered that. Those two are very important. Square of any two positive integers and cube of positive integer. Next, after that, we have come across finding HCF and LCM by fundamental theorem of arithmetic and verifying the relationship between HCF and LCM. Right? It is very important. Look here, HCF, finding HCF and LCM using FTA or by prime factorization. Sometimes they won't give also. Just to find HCF and LCM. Whatever the method you want, you can go for that. Then verification. What is that verification? Verification of HCF into LCM is equal to product of two numbers. Got it? Next, another type. It is also very important. 26 whole raised to the power n. Does it end with 0? You are going to check that. Got it? Ends with the digit 0. Ends with 0 or not. Verify that where n is natural number. Next, you will give a number and that number is a composite. They will ask you to give reason for why that particular number is called composite number. You might have remember that the question is like this: y is 3 into 7 into 5 plus 3 is a composite, right? Composite number. This is one type. Next, another one. Next, another important concept, very important concept is proving irrationality of numbers, right? That is like root 2, root 3, then 2 plus 3 root 5, 7 root 2 by 3, then 11 by 2 root 7, they all are irrationals. Means we have to prove these as irrationals. That is another important. Next, revisiting rational numbers, right? We all know that rational numbers, they can also be expressed in decimal form in two ways. How? One is terminating, second one is non-terminating or recurring. We have a condition for that. For terminating, in whatever the rational number will be there, in P by Q, if Q is of the form 2 raised to the power m into 5 raised to the power n, then the decimal expansion of that rational number terminates, right? Next, in P by Q form, Q is not of the form 2 raised to the power m into 5 raised to the power n, where m and n are non-negative positive integers. If this condition holds good, then we can say that the decimal expansion of the rational number is non-terminating recurring. Based on this also, we have come to know how to express the given rational number in decimal form without actual calculation. And from that also we have come to know one more important point. We can tell after how many digits the decimal expansion of the given number terminates, right? In addition to that, one more point. After how many digits the decimal expansion of the given number terminates. Clear? In addition with all this, we have come across many problems in solving additional problems, right? Please work out all those. Whatever the syllabus I have covered, whatever the number of problems we have solved in these 10 periods, I think they are more than enough in the examination point of view. Please believe us. Okay. So with this, let us stop the class. Practice very well, and on Sunday test will be given, unit test will be given on this chapter. Okay. So once again, thank you very much.